So the first one, right, I can do it two ways, right? I can use it as a log, I can rewrite it as a logarithm, or I can just change the bases so they're the same. And I think for these ones, I'm just going to change the bases so they're the same. So I can rewrite this problem as 3 to the 2x equals 3 squared. And if my bases are the same, the exponents, in order for them to be equal, the exponents have to also be equal. So that means 2x has to equal 2, or x would have to equal 1. So my answer is 1. Okay. Same thing for the next one. I'm going to rewrite 125 with a base of 5. So I get 5 to the 2x equals 5 to the third power. So in order for them to be equal, because they have the same base, the exponents have to be equal to each other. So 2x is going to equal 3 divided by 2. X is going to equal 3 halves. Okay, and then the last one, I'm going to rewrite these as the same base again, as both of them as different bases. So I can rewrite 25 as 5 squared times negative 3x. And I can write 125 as 5 cubed times negative 3x plus 3. So in order for them to be equal, the exponents have to equal each other. So I get negative 6x is got to equal negative 9x plus 9. Add 9x. And 3x equals 9. Divide by 3. Woo! X equals 3. Okay? Questions on those three? Are we okay? Okay, good. So second set says if my bases are the same on my logarithms, which they are, they're log 16 and log 16, then in order for them to be equal, the other pieces have to be equal. So negative 2x has to equal negative x plus 2. So add x. Negative x equals positive 2. So positive x will equal negative 2. And my bases are the same again. I've got log base 9 and log base 9. So I would have 4x minus 3 is going to equal 3x plus 4. So subtract 3x and add 3. So I get x equals 7. Okay. And then the last problem, if I can move the page over here, I've got log base 17 and log base 17, so those are the same. So I've got 3x minus 2 equals 10 minus x plus x plus 2. So I get 4x equals 12. Divide by 4, x equals 3. Okay, do we have any questions? Everyone okay with that? The easy ones, the easy side of it. Now we're going to go slightly harder. And, oops, sorry. We're going to go slightly harder. And it's solving equations by changing to another form. So if I have, basically, I'm going to just zoom in on this part right here. If I have a exponential function, it says a to the x power equals some number. Basically, I'm just going to change to logarithmic form and then solve it. Or if I have log base a of x equals some number, I'm going to change it to exponential form and then solve it. Okay? That's it. So I'm going to change from one form to the other. And remember, let me write that over here. Changing form is if I have log base a of x equals y, I can change that to a to the y equals x, right? It goes both ways. So I'm just going to change the form from log to exponential or exponential to log. So if I look at number 1, it is in exponential form. I'm going to make it kind of big so you guys can see it. Sorry. 2 to no power equals 20. It's 2 to some decimal power, right? Can't really solve it like that. So I'm going to rewrite it as a logarithm. So this would be log base 2 of 20 equals t. And then I'm just going to put it into my calculator, right? Where is my calculator? What did I do with it? Here we go. Sorry. Desmos, where are you? Desmos. And we're going to round it to 4 decimal places, not 4 numbers, 4 numbers after the decimal. So how many ever in front? Don't know. Could be 1, could be 3, could be 4 before the decimal. But I need 4 numbers after the decimal. Okay? So log, you guys are probably going to beat me there. Log base 2 of 20. So t is approximately going to be equal to 4.3219. And that's it. Don't have to do anything else to that one. Where on the other one, the next one, number 2, here we go. Sorry, doesn't want to move very easily today. We're still going to do the same thing, right? So I have log base 2 of 15 equals 2x plus 1. Now I could find out what the log base 2 of 15 is, but you guys know I'm going to get some really random fraction, right? So what I want to do before I do that is I want to do my adding and subtracting and dividing, and then I can put it all into the calculator at one time, so I'm not rounding and rounding and rounding and get my answer a little bit further off. So the first thing I'm going to do is subtract 1. So I get -1 plus log base 2 of 15 equals 2x. Divide by 2. And this whole big ugly thing is what I'm going to put into the calculator. Make sure when you put it into the calculator, I'm going to put it up here. How I would put it in, I would do parenthesis -1 plus log base 2 of 15 parenthesis divided by 2. So if you're using your Apple phone and the Apple calculator, I'm sorry, I don't know how to put it into that one, because once I got Desmos, I never used because you know, with the Apple calculator, you have to put some things in first. It's just kind of strange. So I just switched to Desmos and used my Desmos app for that. So I'm sorry if I don't know how to put it into the Apple calculator. So x is going to be approximately equal to, let's see, parenthesis, -1 plus log base 2 of 15 parenthesis divided by 2. Oh, why did you do that weird thing? Okay, so that one didn't work. Let me try it again. Parenthesis -1 plus function log base 2 of 15. Oh, that's why. Parenthesis, there we go. Divided by 2. Oh, should equal 1.4534. Okay? And then the last one, I need to get the exponent by itself before I switch it to exponential form. So this one I actually have to do stuff to it first. So I'm going to subtract 7, and I get 3e to the x equals 6. Then I'm going to divide by 3, and I get e to the x equals 2. So rewrite it, right? So I've got log base e to the 2 power equals x. And I know it's been a while since we defined log base e, but log base e is natural log. So I'm going to write it up here. Log base e is the natural log. So natural log of 2. So I'm going to put that into my calculator. And you should have a natural log button in your calculator too. Even Desmos has one. It's under the functions in the same place that you find your log. And that's it. So this should be 0.6931. Okay, questions? Oh, Tony's here. Sorry. Okay, let's see. So here we go. So I've got, let's see, what do I have? Log base 5 of 21 equals x plus 1. Subtract 1. So I get negative 1 plus log base 5 of 21 equals x. So x is approximately going to be equal to 0.8917. Okay, so you're supposed to round. I just want to say you need to round that. So I think most of you just truncated it at the 6, but I think there's something past the 6, like a 9 maybe. Let's see. I kept it on here so I could go back and look. 5 of 21. Yeah. 6. Oh, it's 6, 6. So because it's a 6, after the first 6, there's another 6. I have to round the first 6 up to a 7. So, you have to pay attention to the number behind. You have to pay attention to the 5th number after the decimal too. So I've got here log base 4 of 19 equals 2x minus 5. So add 5 to both sides. So I get 5 plus log base 4 of 19 equals 2x. Divide by 2. So x is approximately going to be equal to 3.562. And so I know that this one only has 3 decimals after the end, but it is 3.56198. So if I look at the 8, that means the 9 rounds up. The 9 rounds up to a 10, which means the 1 runs up. So it'd be, technically, I guess it should be 20. That way you can have the 4 decimal places. Okay? And then we have C, which says log base 10 of 347 equals x plus 2. So subtract 2. So I get negative 2 plus log of 347 equals x. So x is going to be approximately equal to 0.5403. Just so you know, on your checkpoint, if you forget to round 1 decimal place, we have a little bit of variance on you. So if you forget 1 decimal, like you forget to round one number, you're going to be okay. Just so you know. But I just want to remind you that you need to think about rounding. So let's see, log base e of 4 equals x. So x is going to equal the natural log of 4, which is approximately equal to 1.3863. And then the last one says, what does the last one say? I have to divide by 4 first. So I get e to the negative x equals 3. So natural log base e of 3 equals negative x. So negative x is going to equal the natural log of 3. Divide by negative 1. So x is going to equal negative natural log of 3, which is approximately equal to negative 1.0986. Any questions? Alexis, I'm going to have to look at your calculator, I think. I'm going to have you share your screen with me and find out what's going on with your Desmos. so we can figure out what's going on with your answers. Because I'm sure that you're putting them in right. I'm just not sure how it's giving you your answers. So we'll look at that today. Okay. So next we're going to change. Now we're going to go from starting as an exponent, we're going to start as a log. Okay, and then we're going to solve it from there. So remember how I said that log base e equals my natural log? It's easier for me if I see a natural log to switch it back to the log base e, especially if I'm going to switch to an exponent. So I'm going to write this as log base e of x equals -1. Now I can't solve it as a log, don't know what it is, so I'm going to switch it to an exponent, so sorry. So I get e to the -1 equals x. Okay, and I think, I need to look. I need to look because I don't know. Some of your calculators may actually have an e, power to e, oops, go away. But Desmos does not, so I can just leave my answer as x is going to equal 1 over e, right? Because it's got a negative exponent. So it's just going to be 1 over e. Remember e, we defined it as 2.71, It's non-ending, non-repeating number. They just named it as e because it was found by mathematician Euler. So which starts with an E, it's EU. So he got a letter named after him. So 1 over E. Okay, so the next one's already in a log. What base is my log? There's no base for it, so what base is it? Yes, base 10. Awesome. So if there's not a base showing there, it's base 10. So I'm going to rewrite it as, I can't solve it as a log, so I'm going to rewrite it as an exponent. So I have 10 to the third power equals x minus 5. So add 5 to both sides. And I get x is going to equal, let's see, 10 to the third power is 1,000. And 1,000 plus 5 is 1,005. 10 times 10 is 100 times 10. Yeah, 1,000. Okay. Make sure I'm doing my math right. And then again, I can't change it. Just like when I had an exponent, I couldn't change it to log unless that exponent was by itself. So I can't change a log to an exponent unless that log is by itself. So I need to do something first on this one. So I'm going to divide by 2 first to get my log by itself. So I have log base 5 of 3x equal. I'm sorry, did you have a question? No, we're okay? Okay, so divide by log base equals 2. Now I have a log by itself, so I can go ahead and switch it to an exponential function. So I have 5 squared equals 3x, and then I'm going to divide by 3. So x is going to equal 25 thirds. That was ugly. And then we have one more example for logs before we send you on your own. And that's, up until now, we've only had one log, right? Even if it was a natural log, we've only had one log per problem. Now, if we look at number 4, how many logs do I have? I've got 2, right? And this is where our properties come into play. So I have, in between my logs, I have a plus sign, right? And in my properties, what does a plus mean? Does it mean multiply, divide, a power? What does that mean? If I want to write it as one log instead of multiple logs. Do you guys remember the 3 rules we had? It was 2 times ago. So let me see if I can remember them and write them down correctly. It says if I have log base b of m times n, that equals log base b of m plus log base b of n. And then the next one would be log base b of m over n equals log base b of m minus log base b of n. And then the third one said log base b of m to the nth power equals n times log base b of m, right? So those are the rules I'm talking about. So if I have a plus sign here, which one of those rules would I use? The first one, the second one, or the third one? It's got a plus sign in it. Yeah, I'm going to use the first one, right? Because this is the one, highlighter, with the plus in it, right? So if I have a plus here, which is what my problem looks like, then I'm going to rewrite it like this. So I'm going to multiply my two things together. So I have log base 2 of x minus 2 times x equals 3. So now I can rewrite it as an exponent because I only have one log. Remember, I can't rewrite it as an exponential function until I only have one log, which I have now. So now I can say 2 to the third power equals x times x minus 2. So now I have to solve this. So it looks like it's going to be exponential here. So 2 to the third power, 2 times 2, 8. Equals x squared minus 2x. So subtract 8. So I get 0 equals x squared minus 2x minus 8. Do you need something, babe? Okay. And then I'm going to factor. So give me some room over here. Give me two numbers that multiply to be -8 and add to be -2. So that would be -4 and +2. So 0 equals x minus 4 times x plus 2. Okay. So I have two things multiplied together that equals 0. So one of those things has to be 0. So I get x minus 4 equals 0, or x plus 2 equals 0. So x is going to equal 4 or -2. So now I have to check my answers. Just a minute. I kind of talked about it a little bit on Tuesday. So if I put, why I have to check my answers, because I have this x by itself right here. Do you see that? It's just an x. So if I put a 4 in there, I can find log base 2 of 4. That's fine. But can I find log base 2 of -2? Is that possible? Is there a log base 2 of -2? That's my question to you guys. Is that possible?
No.
No, that is correct. Because remember, if I write this log base 2 of -2, 2 to what power equals -2? Is there any power out there that's going to change 2 to a -2? No. So that means that -2 is not an answer. The only answer that is correct for this problem is x equals 4. Even though I have two answers, one of them is an extra, what do they call? What's that word? It was just in my head and now it's gone. Extraneous. It's an extraneous answer, so it's just extra. Okay? So if I have two answers, or if I have a negative answer, I have to check to make sure it's going to work in my problem. Okay? All right, so let's do the first 3 first here, and then we'll do the... Okay, so add 5, because I got to get the log by itself. So I have log base 10 of x equals 15. So to solve for x, I'm going to say 10 to the 15th power equals x. I am not going to make you write 10 to the 15th power out. 10 to the 15th power is fine as your answer. Okay, so it'd be, if you wanted to, you could. It would be a 1 with 15 zeros after it. So if you wanted to do that, you could. So for part B, I'm going to rewrite this as log base e of 3x equals 2. Then I get e squared equals 3x divided by 3. So x is going to equal e squared divided by 3. And you can leave it that way. Or, let me see, I think I have the answer here somewhere. If I don't have it, Brooklyn had it. So you can put it into decimal form, which is 2.4630. Okay? Beautiful. And then C, the log is by itself. So I would get 7 to the 3rd power equals, don't not need a parenthesis, x plus 4, subtract 4, and I get x equals 339. Okay. Part D, I need to get the natural log by itself. So I'm going to subtract 5. And I get 2 natural log of x equals -1 divided by 2. Natural log of x equals -1/2. So log base e of x equals -1/2. So e to the -1/2 equals x. X equals 1 over e to the 1/2, which is approximately equal to 0.6065 if you want to put it in decimal form. Okay, and then e, everything's by itself. Okay, so 3 squared equals 4x. Divide by 4, x equals 9/4. Beautiful. And the last one is a plus sign. So that means it's times again. So I get log of x times x plus 9 equals 1. So 10 to the 1st power equals x squared plus 9x. Subtract 10. And I get 0 equals x squared plus 9x minus 10. So I need two numbers that multiply to be -10 and add to be 9. Well, that's 10 and -1. So it factors to x plus 10 and x minus 1. So x plus 10 equals 0, or x minus 1 equals 0. So x is going to equal -10 or +1, and it cannot be -10. So x equals 1. Questions? Nice job. We have like 32 minutes, no, 22 minutes, 27 minutes, something like that. I don't know, because I can't do math today.